everyone. Welcome to the Imaging Wire Show. My name is Jake Fishman. I'm the host of the show and the editor of the Imaging Wire. And we have a great episode for you all today. We have Dr. Charlene Liew and Dr. Nina Kottler. Dr. Liew is from SingHealth in Singapore, and Dr. Kottler is from Radiology Partners. I think a lot of you folks who are watching know of them and have heard of them. And this is going to be a great show. We're going to be talking about AI. Taking a platform approach to AI adoption and some really unique and cool new ways to use multiple AI solutions within a single clinical workflow. Without further ado, Dr. Liew, Dr. Kottler, welcome to the show.
Thank you very much. Thanks for having us.
Thanks, Jake. Thanks for having us.
It's really good to have you here. Well, we're going to jump into all those topics. Right before we do, if you could just share a quick intro to yourself and what you do professionally, and then we'll get into it. Dr. Liew, maybe you can start us off.
Sure. Thanks, Jake. So thank you for your kind invitation to have me on your show. Just briefly, I wear two hats, one for my institution and the other in a leadership role. So for the institution, SingHealth, I represent the diagnostic radiology innovation side of things. As Director of Innovation for Radiology. And I'm also the Deputy Chief Medical Informatics Officer for my hospital in Changi General Hospital, which serves the east side of the island. For the other hat that I wear, I'm a representative of the radiologists here in Singapore, in the role that I play as chapter chair of the for diagnostic radiology in the College of Radiologists of Singapore. So very pleased to be here, and I hope I'll be able to share with you my own unique perspective as we implement a single platform solution in this part of the world.
Well, hi, everyone. Thank you for having me, and it's wonderful to be able to talk to you all. I'm an emergency radiologist. I've been practicing for, over 17 years now. My background actually is in applied mathematics and optimization theory. I didn't realize I wanted to be a physician or a radiologist until later in my career. So I did that for a while, but it just ends up in where I am right now, which is the Associate Chief Medical Officer at Radiology Partners. I'm combining both of those. I'm combining my applied mathematics and my career as a clinician together to figure out how we can use AI to drive value in healthcare. The practice I work for, Radiology Partners, is the largest radiology practice in the US. We serve about 10% of all of the US, all of the imaging done is done by us. We're in, I think, about 35 states, and we serve all 50 remotely. We read, I think we serve approximately 3,000 different radiology sites or sites that we read for, and we've got that many, about 3,300 radiologists.
To start us off, so I spoke about it a little bit at the beginning about adopting and implementing multiple AI solutions through a single AI platform, which I don't know if people who know about that are like, oh yeah, obviously, and the people who don't are like, what? Those are just a bunch of words. What did Jake just say? So before we get into it, maybe Dr. Kottler, you can help just give us a baseline understanding of what that means.
Sure. Yeah. I think everything's so nascent that a lot of words get thrown around and we all kind of wonder what they really are, what they mean. So let's just take a minute to level set to make sure everyone understands what we're talking about when we say that we're using an AI platform. So right now, there are multiple, like hundreds of AI vendors, even just in healthcare alone, and even more FDA cleared and approved AI solutions for radiology. But because the technology in the healthcare industry, or at least AI in the healthcare industry, is so new, there really aren't any global standards that are adopted for it. AI has only been around in radiology, and that was the earliest in healthcare since around 2016. So we're sort of flying this plane or creating it as we fly it. So each AI vendor, they create their algorithms, their models differently. And each one accepts different data components. They each produce different outputs. So imagine if you wanted, or your organization wanted to use several AI solutions from different vendors. Well, without a platform, you would have to integrate your data, so your DICOM, your HL7, with each vendor independently. So if you want to do 5 vendors, you've got 5 integrations of your data. The one does not help you do the next. Each one will have different requirements. Each will have a different output that needs to be integrated into your clinical application. So not only do you have to integrate your DICOM, your HL7, your data to them, right? The ingest has to be integrated, but also the output has to be integrated to get back into your multiple clinical systems. And that is a huge amount of work. As you scale, this integration cost is just going to scale linearly. The work is going to scale linearly. And it just becomes increasingly difficult to manage that. You just can't manage multiple integrations, I think. So as a consumer, we need to figure out how, once we go beyond just purchasing one model or several models from one vendor, how do you start doing that for multiple vendors? There's no one vendor that's going to do everything. It's impossible with the amount of AI that's out there and the amount of things that we need to do. So what is a way that we can manage that? Well, that's what a platform does, right? A platform is meant to ingest all of the data in a standard way, to ingest or take in every different AI model that would be there, and then to have the output come out in a very particular way so that you only need to do one integration, but you get access to multiple different AI solutions. So I think that is the basics, right? That's the basics of a platform. There are additions to that you could do. Right now, if you wanted to purchase an AI solution, well, great, you can do that with a platform. You want to be able to do the same just to test out an AI vendor or an AI model, because you're not going to deploy it and purchase anything until you test it out. So your platform not only has to help you integrate an AI vendor, but also to test it out, and to test it out, whether that's a head-to-head for different models that you're comparing to each other, or it's just one model that you're using on your own data set to see how it actually does, and not relying on what was shown to the FDA. I think the other things that you need a platform to do are to monitor the data, because you have to know over time, is that accuracy falling off? Because your data is changing. We get new diseases that come up. We have new protocols. We have new scanners. All of that is going to change the accuracy of the data. So a platform should be able to monitor that accuracy over time. And then if you want to create an AI model yourself, there are some that want to do that. There's something called ML Ops, right? Machine learning operations. And a platform, if you want that, should be able to have that capability. And that's meaning like having a place where you can do your data labeling, your curation, and your algorithm creation. So to me, all of that data management is what separates what people used to call marketplaces from what now people are calling platforms. A marketplace is a place where you can offer a consumer a single location to shop for a bunch of different AI models. And it has to do some of that back-end integration, but the amount that you really have to do, I think people underestimated when they created marketplaces. And that's why so many of them didn't work out so well. So platform to me is a more holistic approach where you're incorporating in not just the marketplace component, but you're solving all of those data movement components that you need to really be able to not just purchase an AI model or 2 AI models from different vendors, but to make them work coherently together. So that quick summary of a marketplace and a platform.
One of the things we're going to be talking about is using multiple AI solutions within a single workflow. And I guess maybe Dr. Liew, if you could just help clarify what exactly that might mean for folks who haven't done that yet.
Sure. So what you might consider a multi-AI solution is, it depends on your institution. So there's no one size fits all definition, I think. For a busy academic teaching hospital like ourselves, I think what that means is, we are able to deploy not just commercial off-the-shelf solutions, but we're also able to deploy AI models that have been built in-house by our researchers. And We have a thriving biomedical scientific community here in Singapore, and everyone's heard about AI, and everyone wants to get, onto the bandwagon and test out their AI models. So there's a huge demand, and so I think a multi-AI can also provide the capability to do that, to test our own, to test bed our own developed models as well. So that's how we see it in from our perspective here in SingHealth in Singapore.
And there's also people that I know that are using platforms to build these models like you're talking about, to test them out. And then that data can be used to get FDA clearances, at least in the US.
Absolutely. So not only is it somewhere we can deploy our solutions in the research environment, but we can also deploy it prospectively into our workflows and to validate the accuracy of these models on real patients, so that we can generate the data that's required by the various regulatory bodies. So I mean, it's a key requirement of the FDA for Singapore, the Health Sciences Authority, that we actually prove and validate that these models do work on our local population. So having the ML ops capability and having the ability to deploy in real life day-to-day work is extremely crucial.
Dr. Kottler, is that use case consistent at a large radiology practice?
I think a lot of radiology practices are not actually creating their own AI. That would be the minority that would be doing that, but many of them need to figure out which AI model is generalizable and works on their data, which AI model causes or brings in a return on investment. And although it's when you're talking about taking care of patients, it's a shame that we have to talk about the business side. But if you don't have something that can pay for the cost of innovation, then you're never going to have a sustainable technology that's available. And we have to figure that out. I think it's part of why AI has not been deployed everywhere, is because we haven't figured out all of the business cases that are there. So being able to test for radiology practice, I think a viable business case is being more efficient. Like, we don't have enough radiologists in the entire world to do all of the radiology work that is out there. So if our radiologists could be more efficient, not by working harder, but by working smarter, then yes, that would be a business case that actually could pay for the cost of innovation. And because private payers and CMS is not paying for it, we've got to figure those things out. So that gives us the opportunity to say, is there an ROI? Is there approved efficiency? Do the radiologists enjoy using these tools? Nowadays, there's multiple different AI vendors that have the same kind of tools. So how do you pick which one is going to be the best one? You want to be able to just look at their data and say, oh, well, this one's got the best, AUC. That really has nothing to do with which the best vendor is. The only way to identify which the best vendor and best model is if you're working with them. So you actually want to deploy it. But when you do that at scale, or when you want to deploy, let's say, 10 different models, it takes months and months to do that deployment. So what you'll find over time when you try to do this is that you want a platform or a place in which you can do all of this testing and do it in a shorter period of time, so you can make decisions more quickly. Because if you're not making decisions quickly these days, you're being left behind.
So when you're doing that evaluation, say 10 or 5 or however many in there, solutions that are intended to do the same thing, how would you set up that evaluation?
I can start, because there's a few things when we're looking at a AI model. Like, you have to decide, what are you looking for, right? What is success? Because if you're just doing it willy-nilly, you'll end up kind of being all over the place. And like I said, because there aren't standards yet in how we do these things, no one has that list. So you have to come up with it yourself. I would come up with it before you start going into any evaluation, or you'll spend a whole bunch of money for not getting the output you want. So for us, when we've done that, we've kind of defined it over time. We look at, maybe 4 or 5 different things. So one of them is the business case that I talked about. What is the ROI? How are you going to be able to afford to pay for the cost of innovation? And if you are a radiology practice, that's very different than if you are a hospital Even an outpatient imaging center would have different criteria. So depending on what your business is, you're going to have a different ROI. So you have to be very specific about what that is, define it, and then you can use that to test. The second criteria, or the second couple criteria we use are clinical criteria. For us, it is essential that we have to, if we're going to be adding technology, that technology drives value. So value means that it can't just cost less. It also has to improve outcomes, or if you can't measure outcomes, which are very hard to measure if you don't have EMR access, et cetera, or a lot of time, at least measure quality in some way. So define what that is, because you want to be able to look at that. The third kind of clinical criteria is the accuracy. We don't necessarily just trust what was published for the FDA. That's a useful starting point, but it really has nothing to do with how it's going to work in your environment or with your own data. So we want to evaluate the model against our own data and look for what the accuracy is. And we can talk about how we do that a little bit later if you want, because that's a whole discussion on its own. Because the numbers itself don't tell everything. We don't look and say, well, this one has an AUC of 97 and this one has an AUC of 98. We're choosing the 98. That's not how you do it. It's actually a little more complicated than that. The fourth thing, which is all of these are equally important, is the technical capability of the individual vendor, or if you have a platform, of the platform, because you need to be able to integrate with them. And some of them can do that well, others not as well. Some of them, it takes a lot of work. It's not plug and play. You're going to have to be working with the group to do this. So you want a group that's technically willing to take the time and able to manage that with you, because you are going to run into problems. Even though DICOM and HL7 are standardized, that's like a tenth of the problem. Most of it is not standardized in the way you actually need. So you're going to need to work together. The vendor has to have a good technical capability. And at least for us, where we're coming from, if they are able to do it for 100 patients, that's very different from 1,000 and 10,000 and 1 million. And we're at 50 million. So when you get to that, it's just a completely different scale. And a lot of the groups that can do it for 1 million can't do it for 50 million. The last piece that also, and that's going to be important, not just for my group, I think for everyone, you need something that's going to scale. There's more consolidation happening in medicine, and you don't want something that, as you add on more and more models, suddenly it doesn't work as well. So that would be cloud capability. And then the last I would say would be the vendor itself, or the platform who is representing the vendor. You want to be able to work with someone who has a similar alignment. It is easy to work with because, like I said, none of this is standardized. It's not plug and play. And so you're going to have to define together what you want to do. And that means you have to be able to have a good working relationship. So we look at all of those factors. Some of them are quantitative. Many of them we make quantitative when you're doing a comparison. Some of them are qualitative, but you can do all of this, or a significant amount, on a platform.
Dr. Liew, is the way that you would, run your evaluations, is it similar, and how has it been different? Comparing like a single AI platform versus a multi-AI platform that can run multiple models at the same time.
Absolutely. I couldn't agree more with what Dr. Nina's, so cogently explained. I think she's covered everything. What I would add to what she said is that, developing the relationships with the vendor that you're working with, or the companies that you're working with, is extremely crucial. And that's the path that we've taken here in Singapore for we call it a call for collaboration, in fact. So it's called that because in recognition of the fact that we don't intend to build a platform that is bespoke to our needs on our own. We don't intend to do all the engineering and all the integrations using only our in-house capabilities. So we are reaching out to industry and all the commercial players out there to see who can bring value to the partnership. And we see ourselves as equal partners, and we see ourselves as building a platform together. So I don't think anyone has all the answers, because simply because we're still literally, as Dr. Nina said, we're laying down the tracks as the train is moving. So it has to be a collaborative effort. And, we're going to learn a lot about how we're going to engineer this in a way that's, number one, sustainable. Number two, that can really, truly deliver clinical value to our patients in the future. So the answers are still out there. And I think, it's going to be a people question. We have to find the right people. We have to, be able to work together in teams, and we have to problem solve along the way.
So one of the things that I'm particularly curious about with the multi-AI platforms is this kind of change in the paradigm where evaluation used to be, and many times still is, or usually still is, either or. It's like, do I use this solution or this solution? And there's a potential there it could be, this and this other solution within the same workflow. Is that something that you've had experience with?
So with that, you would mean, let's say you have a chest CT.
Yeah.
And that chest CT can be evaluated by one vendor that maybe is detecting nodules, but also by another vendor that may be detecting coronary artery calcification. And those are two separate vendors. And you want to send that chest CT to both vendors. Is that what you're talking about?
It could be that, or it could be, in theory, like two coronary artery algorithms that both do a good job, but maybe both have their cases where they might over or underdiagnose a given patient, and kind of using multi-AI platforms that way, where you can actually get it right both ways more often.
Yeah, I think that's a really interesting point. So imagine you have 5 different AI models that are all detecting, I don't know, let's say aortic dissection, or no, let's do something more common, pulmonary nodules, and they're making detection and diagnosis. And they're all trained on different data. So they're each going to have their own accuracies, the areas that they work really well in, the areas that they don't work well in. And what's interesting when you get into it is that each vendor is not holistically, hey, they work well, they're 96% on everything. That's their average. But what happens is that they may be 100% on a certain type of patients or a certain type of exams that they've got a lot of data for, and then not as good for other patient types. So what you're saying is that what if you combine a whole bunch of them together, and you're not going to say that a study has a positive lung nodule until 2 or 3 of them, or you send it to the right one for that subset of patients. I mean, I think ultimately that's where we need to go if we're going to be improving quality to a significant degree, is not just to be saying holistically, let's send this one study to this AI algorithm because it does better on average than all of them. You want to look at that individual patient and that individual case and say, well, where does that individual case should that go? And I think that's a really interesting way that we can do it for the future. It's instead of kind of population health medicine, it's more precision, it's more precise. Mm-hmm. And then the big question comes into, well, how do you afford that? And how are you paying for these things? And I don't think we're quite there yet, but I do think it's a super interesting way to get more precise about what we do. And the opposite is true as well. What if you want to make sure that, let's say, a chest x-ray, there's batching right now for chest x-rays that say normal or abnormal. Well, you're going to get some false positives in the ones that say normal. You'll get some positive studies. What if you combine the results of all of them together and make sure that they all agree before you say a study is normal? Then you've got multiple AI algorithms with different points of view that are all agreeing before you get to it. That's going to save the radiologist far more time than any single solution alone. I think those are really cool things that we can think about in the future.
Dr. Liew, is this something that you've looked into in your institution, or you have some thoughts on this?
Yeah, absolutely. So we've actually explored this idea with partners, Kottler, and what they've done is they've actually combined several different AI models into the same interface, so that users can actually look at the combined outputs of several AI models. So it's something that we've explored with our partners, as I mentioned. The other example that we've actually used this is in research. So we've done something called Ensemble AI. And an example that comes to mind is when we built an algorithm to detect the presence or the absence of COVID-19 pneumonia on chest X-ray imaging at one particular hospital, Tan Tock Seng Hospital in Singapore. And our team in Changi General Hospital, we developed an AI that was able to prognosticate the likelihood of mortality based on chest X-rays as well. So we actually found a way to combine those two models so that you could detect and then you could prognosticate at the same time. So those were that's an example from the research side of things. But obviously, as we move into deployment, we can also do the same with Ensemble AIs. And that's only possible if you have a platform that's able to house all these separate models.
It takes a huge amount of coordination to do that. I mean, even today, you're going to want your, like, say, your chest CT be evaluated by multiple different models, and they may be models from different vendors. And there's no way to coordinate that. If you're trying to integrate on your own, you'd have to do it in a kind of series way, but really you want to do it in parallel. And then you've got to figure out, well, how do I combine that information back together and present it in a cohesive way to my radiologist? And what if one piece of data gives you the answer? What if one of the AI models gives you the answer, but you're still waiting for the other one and the rad's about to open the study? Like, what do you do? There's all of these scenarios and questions that have to be determined. And I just don't think that any one practice or hospital system is going to be able to come up with the answers to those scenarios and the technology that you need to monitor and manage that data flow without a platform.
So when you're evaluating a platform, understanding that there's new AI models that are coming out, I don't know, every 2 weeks, it seems like, I know, because I'm writing about them each time when they come out. And you have your platform that you've decided to invest in. How do you basically select your platform so that it, is future-proof for all these new solutions that continue to come out?
I can start because you have to think a lot about what you want your platform to do for you. Like for me as a radiology practice, we're creating some AI, but mostly we're out there looking at AI models and purchasing them. We want to see which one's better. So that's going to bring me down a different side of the platform capabilities than it will Charlene. She'll be looking, significantly at the MLOps capabilities, et cetera. But if you're talking about the other side, what we think about is there has to be, it's helpful to have a vendor that has the marketplace knowledge, the availability and knowledge about and integrating those different models that come through. There are some vendors that they all do it a little differently. There's some vendors that know the market really well, and others maybe that are very specific about what parts of the market they're looking at. I find it helpful because it's really hard. Aside from you, Jake, who's doing a great job at it, I find it quite hard to keep up with all of the stuff that's out there. It all changes so quickly. So if you have a partner in crime that can kind of help you with that, I think it's really useful. The other part is once you have that, so marketplace capability, I want to look at how do I evaluate the accuracy of an AI model? So my platform has to have the ability to not only take my data and ingest my data and integrate that into the AI model, but to visualize it in a way that's really easy for me and quickly for me to understand. And I do think not just looking holistically at the whole thing and the average, but the different points along the ROC curve or the points on the ROC curve at which that model is FDA cleared. And also looking at the patient subsets, because I want to know where it works well and where it doesn't. Because even if I do choose one model instead of multiple, the way we were talking about before, I want to be able to go to my radiologist and tell them, here's the kind of patients or exam types that this model doesn't do as well on. And you need to be really aware because I want you to be, more strongly influencing the outcome in this kind of case. So you want to be able to have that baseline knowledge, and your platform has to be able to create it for you. The third piece is ingesting the data. That is not easy. I think that there's two ways of doing it. One, they could just take in your data and say, hey, send me everything. But another one, because what you have to do when you ingest the data, you have to figure out where to send it and which pieces to send. So I call this data orchestration. You've got to send the right images or report or whatever other piece of data. The right images of the right series for the right patient to the right AI in the right time. Like there's all of these things that you actually need to do. It is much more difficult than just when I say, hey, let's just send on the DICOM and HL7. It's much more complicated than that. So having a really strong orchestration capability where they're using computer vision to actually look at the images instead of just using the DICOM tags, I think that makes a stronger model. That's going to give a greater ability to the data ingestion. The fourth piece would be the data distribution or the output. You need one that has that strong technical capability to output into whatever your clinical applications are. And some of them have really great APIs. Others, like our VR systems, don't. So you need ones that can kind of build their way into those systems to make it better for you as a radiologist. The other part is kind of what we talked about in the last section when we were talking about a more sophisticated capability of doing data management. When you've got multiple models that you're using, does that platform have the ability and knowledge to know which one to send where? Can they send it to two places at the same time? When they're getting that data back, are they consolidating it together in a way? Are they monitoring it so that you can know if, hey, I've gotten all the results I need and now I'm going to send it along? There's just a huge amount of components there. I think the last couple of pieces would just be service. These things will go down. You'll get used to using them. You don't want them to go down. It happens. Does that group have a good service capability where on a Saturday night, in the middle of the night, they're going to be available to help you? And then there's cost. Cost always comes into play.
Dr. Liew, you have a unique perspective, at least compared to, what we do here in the States, usually in that I believe you work for a public health system, right? And then also an academic center. So I think a lot of the things potentially that Dr. Kottler just talked about are shared, but there might be some unique components. When you're trying to make sure that you're selecting a platform that is going to be relevant into the future and meet your needs, are there areas where your criteria might be different?
Right, precisely. I think I would say that 90% of our requirements are shared with Dr. Nina's experience. So in the private sector, but the only minor differences will come in terms of the data security requirements, which are formulated and regulated by the government. So we have quite stringent criteria that we have to meet. And personally, I feel that if we deploy one single platform solution, it's much easier to ring fence the security around that platform. So, and that in turn, that brings down quite significant amount of costs involved. So those key considerations came in, at several points during the time that we were planning to acquire this or develop this platform. So that's one. So the cybersecurity is a major issue. I guess the other thing that Dr. Kottler mentioned, which was really striking for me, is the data visualization capability of the platform is very crucial for us. If, in the process of generating research, in the process of, visualizing how the data is shifting over time, many of the commercial AI models that are available to us have been developed outside of Singapore. And so the ability to visually detect any shifts in terms of the accuracy of the model on a data point, data plot is really useful. And also, I think personally, for me, as a clinician, as an educator, and as someone who's championing AI here in Singapore, I like to get my juniors involved in research and AI research as well. And there's no better way to show them, data in action, the visualization and the plots and, the confidence intervals and the F1 values, and to see that and to see data move in front of their eyes. I think that's very powerful as a teaching tool as well. So those were the other key differences in terms of how we decided who would be the best partner to work with.
So you have your platform selected, and maybe you've selected a series of AI models to evaluate and to validate. When you're doing that validation process, what are the things that you're looking for? And as after they've passed initial validation, what are the things that you're looking for as you deploy them out to specific workflows or sites?
Right now, we're currently deploying it in a few pilot sites. So we're starting off in phases. And eventually the rollout is planned to go across the whole island. So we're deploying in sprints. So I strongly believe that, perfection is the enemy of progress. So we're not aiming for perfection. We're aiming to roll out a basic platform initially that can, number one, build in all the connections, integrations required to modality and to risk packs. And that's the minimum viable product, so to speak. So we're trying to do that, accomplish that first. And then subsequently, when we've done that for a few key hospitals, we'll pilot a few AI models on the platform to see if if the day-to-day workflow is flowing smoothly, if the radiologists are happy with the way that the models are functioning, if the vendors are able to meet the service level agreements, no downtime or minimal downtime and response time to IT issues and that sort of thing. So it's very much a on the ground kind of deployment. We're really focused on the operational issues initially. And then once we've successfully piloted that, then we'll move on to focusing on the research side of things, ML ops. And then subsequently in the other phases, we will deploy to the rest of the public healthcare institutions in Singapore. So we're very much focused on just the operational side of things initially.
Dr. Kottler, when you're bringing in AI solutions to validate, what are the things that allow you to gain confidence in those solutions?
The testing and the evaluation, we have a group of radiologists that work with me, and we have additional training and knowledge about artificial intelligence. And that group will go in and do an initial evaluation, and we sort of do things in 3 phases. We start with an evaluation of several AI models to compare one against the other, and we're just looking at what the usability is like, what the accuracy is like on our data, how we can come up with those things that I mentioned in the past, where we try to determine if how we can educate our radiologists and if they will accept it. I mean, that is essentially our job. If we roll this out to radiologists, is it going to provide value to them? Are they going to accept it? And in that diligence period, we're pretty much looking at not just frank numbers, like I was mentioning before. We're kind of weighing things. Like a radiologist is going to accept something if it has some cases where they're really wowed by them, right? If they're fantastic pickups and you're like, oh my gosh, I would have missed that. That's wonderful. That's a huge value. So you weigh that part against the amount of false positives that you get, because there's always a balance between sensitivity and specificity. And that's essentially what you're looking at. So when we go in and do our first part of our evaluation, we're trying to pull out, like, are there great wow cases? Are there wonderful pickups that we think would be really impressive to our radiologists? And what is the positive predictive value when we weigh those against each other? When we're looking at the positive predictive value, which is if you have an AI model, and it tells you that the study is positive for something, how often is it actually right versus giving you a false positive? So when we look at that number, we're looking at a couple of things. One is, are you getting a lot of false positives? Okay, most of the time, frankly, you are. You're going to get a lot of false positives if you're going to have a really sensitive model. But Are those false positives things that you could quickly explain away? Like, oh, they happen on studies with motion artifact, or they happen on this type of exams. And you could learn those, teach those to your radiologist and set expectations. That's kind of what we're doing in stage one. And we can do that fairly quickly, in probably a couple of weeks, generally with some kind of platform that has integrated the AI and integrated some of our studies. We can go in and do that test. After we do that, it's similar to what Charlene was saying. We're going to roll that out then in practice at a couple of places. And when you do that, you've already picked which AI model you want. You know that there's some kind of ROI. You know that there is a good enough accuracy that we think the radiologist would like it, but you haven't actually rolled it out into their workflow. So that's what you have to do next. You roll it out into their workflow at a couple of places, work out the kinks, the orchestration of how you're going to educate people and where it's going to fit. You do that before you roll it out everywhere. So we go through the 3-stage model to make sure that we learn along the way.
Is there a certain thing that basically allows you to know that a solution is ready for clinical usage?
I don't think there is a prescribed set of criteria out there, but generally there's some deal breakers, and I think the major one is that, the model accuracy must be safe. And we have to demonstrate that to our healthcare leadership, the senior leadership level. So we actually have to bring that to the medical boards and to show them the AUCs and to say that, look, it's safe. And I think with, deployment together with radiologists, overreading or being part of the loop, it won't harm patients. I think senior leadership needs to be assured of this before a product or a platform can actually be used on day-to-day practice. So I think it depends. Again, there's no one size fits all answer to that. It depends on your institution, depends on what the ROIs are, as Dr. Kottler mentioned. It depends on what your institution feels is an area of need, and what are the pain points for your radiologists in general. I think if you can address those things, then adoption won't be an issue. I think people will actually be more than happy to use AI.
We have a similar thought process. Security, as Charlene mentioned before, is a huge one. Like, we're not going to roll anything out unless it is proven to meet our security requirements. We also don't roll anything out unless it's FDA cleared. Now, you can, if you're doing it under IRB and maybe have a smaller group of people doing that, or you're not going to sell it, et cetera, you can roll it out under IRB. We tend to roll things out after they've been FDA cleared. We also won't roll it out if the RAD satisfaction is not met. And we find that first in our due diligence, if the RADs don't think that balance is working right. And then after the due diligence, when it's rolled out in an actual workflow, if we can't get the workflow to work, then ultimately it's not worthwhile. And of course, this is assuming that there is a business case ROI and that you are driving value. If you don't have that, you don't even get started.
Maybe we could do some advice for the audience. So for the audience out there who might not be leading AI at the scale that you are both leading AI respectively, both within your organizations and your roles, but they're looking at platforms to handle validation and deployment and potentially use multiple AI solutions within a workflow. What are the things that you would recommend that they do to plan for that and decide that the platforms are right for them, and then go about kind of doing their selection process from a platform perspective? Dr. Kottler, maybe you could start off.
Yeah, I always go with education and getting informed. I didn't start off knowing anything about AI in around 2016. And the way that I learned was I started reading things. I started talking to vendors and asking them questions. They know so much and they want to talk to you about it. Use their expertise. I followed people on social media that were influencers and knew more than I did and had deployed more than I did. I went outside of the US to make sure I saw what was going in other places. I would go to different conferences. RSNA is coming up, and that's a wonderful conference to both meet with vendors and to listen to the multiple talks that they're going to have about AI there. There are some other societies like the Society of Imaging Informatics and Medicine. That's a wonderful society to learn about. So there's plenty of ways to get informed. And I just suggest that don't be afraid of it. This is coming, embrace it. It's going to change what we do in a good way, because it's going to help improve care to our patients. So do that. You can help learn about platforms. You can learn more about what it is that your needs are and which groups can manage those needs, and hopefully choose a solution and a partner that is best for you.
I completely echo what Dr. Kottler has mentioned. I think what she said about, reaching out to the community is essential. I've met so many inspirational people along the journey, and, I've definitely not learned anything on my own. It's all been a process of meeting people, speaking with them, attending conferences. And I would say the informatics and the AI community is a really great one. And I think everyone's really friendly. So, everyone's open to helping each other. And I think that's one of the best things about the AI journey. And the last key message that, I would like to share with everyone is, get started on your AI journey early and start planning, because it takes, for us, it's taken about 4 years to get to where we are, just in the planning stages. And so it takes quite a lot of time. So, if you're thinking about using an AI platform for your organization, even in the next 5 to 10 years, you should definitely get started early.
It's true. The best learning is from actually trying.
Thank you so much. I just learned so much over this interview. So thank you. And it's so cool to see all the great work you're doing and how you're supporting the radiologists in your organizations and helping them, make better reads more efficiently, which is great. So thanks for coming on. To the folks in the audience, hopefully you learned a lot just now, just like I did. Dr. Liew and Dr. Kottler do a lot in terms of on the research side and the thought leadership side. So check out their work. I'm sure, Dr. Kottler, you have probably other speeches coming up at RSNA, so you could probably be found over there. And also thanks to Carpal AI, who basically helped assemble this meeting and has a great platform that does a lot of things we talked about. So the validation and the deployment and the use of multiple AI tools within a single workflow. So if that's something that you're interested in, check that out too. Thank you very much. Thanks for coming on, and thanks for watching, everyone.
Thanks, Jake. Thanks for joining, everyone.
Thanks, Jake. Thanks for having us.